Next, we have with us Dr. Susmita Rich, a highly valued contributor to the blockchain. Dr. Rich is a senior research scientist at Commonwealth Scientific and Industrial Research Organization, Australia, also the associate professor at the Indian Statistical Institute. She's a senior member of the Association of Computing Machinery and the Institute of Electrical and Electronics Engineers. She is also serving as a mentor to the Kerala Blockchain Academy. I welcome on behalf of KB and KB Women Connect, Dr. Rich to the two-day free blockchain bootcamp for women. She has collaborated with many researchers across the continent and has delivered 100 plus technical lectures around the world. It's a great honor to have Dr. Rich today.
Happy Women's Day to everyone. Thanks for inviting me. And I'm going to talk about data marketplaces and what role blockchain plays in this sort of situation. A couple of to start with is that you have the data marketplaces where you could buy and sell data just like your ordinary goods and services, be it, just like you have Amazon where you have, you could essentially buy or sell commodities. You could have data marketplaces where you just buy and sell data. And over the years, we see that there is a growing demand for data because data helps us to get more insights, make our lives easier. For example, if you are thinking of what would be the best route to travel from one place to the other, you would get some idea about the best route or the most, the least congested route by just being able to get information or glean more information from the data at hand. That is why organizations are typically very data hungry, and as the need for data grows, it becomes very important for users to know what is happening to the data. Could I monetize my data that I'm actually giving out? Of course, you are getting something in return, possibly by the way of services, but still, if there is a way to monetize, why not? We also are very, we also know that that the data that is being stored or that is being collected from our devices are being used for various purposes, and we sometimes don't even know for what purposes. We simply click on the sign, I agree button without even reading through the terms and conditions, and sometimes we are not even aware of what's happening. And we have seen that there are very well-known attacks, or I would say various types of use of data which was not as desired. So while storing data, we need to ensure that the data storage is reliable, it's not tampered with. There is a proper access, meaning that if I'm selling this data to certain individuals, only authorized people will be able to access this data on certain payment, and unauthorized users are not able to access this data. And you could also have various terms and conditions depending upon the legal tenets that govern the usage of data. So, for example, if you look into GDPR, which is the European General Data Protection Regulation, there is a need for protecting the integrity of data, need for accountable storage, need for location-specific. There are location-specific regulations as to where the data should be stored, whether if there are data breaches, these should be reported, and so on. We would like to also look into what happens in the kind of data breach, because data breach is something that could cripple any system. Because one of the things is that GDPR mentions that if you have data breach, you should be reporting this data breach within a certain amount of time, within 32 hours, 72 hours or so. And one of the things that GDPR also says that, you should protect against data breach. And one way of doing this is to encrypt or pseudonymize data wherever possible. And so, for example, Article 32 of GDPR says this, and Article 64 also says that you should render personal information unintelligible. What it means is that if your data is encrypted or anonymized, there is a less risk of retrieving the actual information, even if there is a data breach. And that is why typically it is encouraged that organizations keep their data in an anonymized or an encrypted form. However, when it comes to anonymization, there is no complete, there is not full privacy, and given the utility of data. And some of the other ways of doing is encryption. And but encryption has this problem of being efficient for certain cases. In some cases, it's not as efficient as we often think. And when it comes to analytics on encrypted data, it could be often very challenging. So what we typically do is that when we are trying to build data marketplaces, this is something that we need to keep in mind. So the situation is as follows. So we have buyers and sellers who are typically entities in the whole trade. And there could be owners who upload or outsource this data to some sellers, this in turn is hosted by a data marketplace, and there could be buyers who pay to get the data, and they could download the data, or in a case of a data market, they could actually get some summary statistics of the data. It just depends upon what the buyers want. And this model looks very similar to a marketplace model that Amazon or other vendors, Flipkart or something has. It's just the same. There are sellers, there are buyers, there are people who actually use these these services and Amazon as an intermediary to buy and sell things. Now, note over here that what we want over here is that we want a few things. We want fairness, meaning that whatever content I want to buy, I pay the proper price for it. There is a need for transparency, security, and privacy. It adheres to the regulations, be it GDPR or the California Data Protection Act, or it could be, our upcoming Personal Data Protection Bill. And these are these have to be adhered on whenever you have a marketplace. There is also a need for performance. Like, you wouldn't want this thing to be very slow. You would like to, for example, if you're trying to get some music from, you're trying to download something from, say, YouTube or something, you do not want it to be very, very slow. Or if you're streaming, you do not want it to be very, very slow. So performance is a key issue, and then we also would like to have that the host or the intermediary is unaware or is oblivious to the data, which is actually a very difficult thing in practice, and that is where the difference comes when we think of a marketplace that are in place now. What it means is that without knowing the content of the data, it is very difficult to ensure this trade. But if we would like to have this feature enabled in the protocol, it would make things much easier, or much, I would say, much privacy preserving. So what it means is that the intermediary does not know what data it is dealing with. It is simply being able to give the right thing to the right person. And this is something which seems to be like a fairy tale. You think about it, that your Amazon service provider does not even know what thing is being bought and sold. But there is a difference with the data versus, these tangible things. And one of the things that we try to do is make the host or the intermediary oblivious to the data we are storing or aggregating. Now, to this end, I would like to mention that any three-party trade is just, impossible. It cannot be fair unless and until there is an intermediary. And this, for example, let's just take an example. Suppose you have two persons, say Alice and Bob. Bob has the data, and Alice wants to pay to receive this data. So what happens is that Bob gives this data, and Alice pays the price. But how does Alice know that this is the data that it has asked for? And even if she knows that this is the data she has asked for, what is the guarantee that when the data is put in the server, and Alice puts the money, what is the guarantee that Alice gets the data and that Bob does not get the money and just run away? So it could happen that Alice gives the money, and this money is paid to Bob, and Alice does not receive her content. Now, if you were to look at in a normal scenario, what would you do? If Alice or Bob is unsatisfied or dissatisfied with this particular trade, they would go to a third party, possibly the court. And then, with proper evidences, the court would decide who is right and who is wrong, or who cheated and who did not. But in our scenario, that is what we are trying to mimic with the help of a blockchain. So what we would like to do is that Alice and Bob, they get their fair share, be it the data or the money. And then there is a trusted arbitrator who can deal with this. And we bring in the blockchain to play that role of a trusted arbitrator, because not only does it help in arbitrating this process, but it also can record transaction undeniably, and that it is, you could also have a native cryptocurrency which can help in the incentivization process. So with this, I would like to say that, you could possibly have such a kind of a trade, data trade, which is blockchain enabled. Now, as a word of caution, I always say that, not all applications are actually translated or gain much when you translate it to the blockchain-based solution. So this is a word of caution for everyone who is using blockchain for applications, that do I really need a blockchain? And if at all I need a blockchain, what do I gain compared with the traditional approach of not having a blockchain? And if you cannot justify, if you do not have sufficient reasons, then don't go for a blockchain. Because, when you introduce blockchain, there are other things in place. You need to make it efficient. You need to decide what kind of a blockchain. You need to understand that how blockchain would help in such a problem. So it's always good to, before you start implementing, or if you start designing the whole process on a blockchain, ask this question again and again. Is it worth? What am I getting? What am I losing? Will I get a good performance? Will I get something, at least a better security, better performance, or will I get at least some feature which is not available in the traditional approach? And this is very important to figure out in the first place before you start any application. If there is anything I would like you to take away from this talk, is that ask this question again and again when you try to design a blockchain-based solution. Do I really need it? What am I getting? And I assume that many of you know what a blockchain is. And this is a simple representation of a blockchain where you have, blocks blocks chained together in such a way that the hash of the previous block is present, which means in the next block, which means that if the previous blocks change, then you have to change all subsequent blocks, which is not a very simple process because these blockchains are kept in multiple peer nodes. And this is just one realization of blockchain. And there could be many other, realization of a blockchain. This is just one representation. And often a blockchain, you could describe it as a distributed, verifiable, immutable ledger. So I'm going to try to now say how you would possibly design this marketplace on blockchain. So some of the requirements, as I mentioned, is fairness, transparency, conforming to the regulations, and also the efficiency. So what I'll do now is just to run you through our design, which actually gives you some idea of how this would work. But there are various loose ends that I'm also going to talk about in the process. Unfortunately, this animated thing does not come so neatly, and there are so many arrows, you can get overwhelmed. So let me just take you down the steps one at a time. So in the left-hand side, you would see a seller. In the right-hand side, you would see a buyer. And the seller has some data D. It simply encrypts this data with certain key and keeps a hash of the data on the intermediary. So this you can think of as the data market place. And you would also try to attach whatever conditions you have on the data. When I say conditions, it could be condition of use, it could be some of the regulatory things you would like to enforce. And these are the challenging parts when you try to design that. What sort of regulations, how do you encode it? How do you codify this legal process into smart contracts? So once you have the encrypted data and the hash of the data, the market maker signs it, and all this information is stored on the blockchain. It just gives you way to ensure that the data is not changed. So that is where the non-repudiability comes. Now, the other thing that the seller also does is that it also locks some money in the blockchain. Now, it is some kind of a guarantee, you would say. The buyer requests for certain content and gets back the content, and then it matches with the data with the hash of the data that is already stored on the blockchain. And if there is a match, it's good and good. If it is not, then it says that, there could be a potential problem here. And if it is found out, there is a proper mechanism to find out who is right and who is wrong by doing a proof of misbehavior. And depending upon this, we could actually say whether you would pay a penalty or you would get a prize. So the blockchain helps in a couple of ways. The money, whatever money, to maintain the marketplace, you need some money. So that money is played through the blockchain. The user is able to deposit the money in the blockchain. So note one thing, that this two process where the buyer gives the decryption key to the seller is done consecutively or simultaneously. So it means that the buyer gets the key and the seller gets the buyer gets the key and the seller gets the money if everything goes properly. Else there is a penalty imposed. There is a proper mechanism to do this proof of misbehavior, which I do not discuss at this point because of the lack of time. And towards the end, what I'm trying to discuss is what is the security of such a thing. It is secure against a malicious marketplace. difference in price, everything is transparent over here using this blockchain. So there is everyone gets properly paid. If there is a misbehavior, there is a cheating, then it can be detected very nicely. What we want to do beyond this data trade is often data audits, several types of access control, who gets the data, who does not get the data, who is supposed to pay, who cannot pay, who should not be a valid data user, because it's up to the seller to also decide, is it just an open market? It's not an open market. It's all the market mechanism that goes into this picture. And if I want to encrypt the data to hide it from the market maker or the marketplace, what sort of encryption algorithms should I put in place to ensure that? Because all encryption algorithms comes around their own cost of performance and so on. Now, challenge-wise, it is very difficult to enforce these legal process, as for example, whether it is GDPR compliant, whether it is CCPA compliance, as these legal statements into a smart contract, and that makes things very difficult in practice. And if I were to ask for a summary statistics, how do I verify that the statistics that are returned by the marketplace is actually right? It's not an incorrect value. So how do I verify the computation on this blockchain? So to end, a couple of things that there are three. The most important thing in the marketplace is that you need analytics. You need various sort of consent that I did not talk in details, and it should actually be ethically compliant. So if you look into it from the previous talk, it was also mentioned that you need to have some ethics. What sort of computations you could draw? What sort of information you can glean out of this data? So one has to be very sure about how to incorporate these things in the marketplace. And the other important thing is that you need some kind of a privacy in place to help or encourage users to share their data. So in other words, I would say that all these things are really important to design a full-fledged marketplace. And just, if you just think of a blockchain, there are a lot of things, a lot of contracts to be written in the proper way to ensure each and everything. So with that, I will end my talk and take questions if there are any. It's a very rushed up talk and with all the glitches, but I'm happy to take questions, be it technical or non-technical.
We have a question from Alex Albano. What could be the example of data marketplaces on blockchain?
If you are asking if there are already existing market, examples of marketplace, so there is something called the Notion protocol, which essentially does this. There are various other, startups in this space, which provide certain services, which are blockchain-enabled data markets.
We have a question from Rama. The question is, how does a simultaneous completion of transaction happens, like money and data transfer at the same time?
Yeah, these are enforced using the smart contracts that I talked about. So the contract itself is written in such a way which help to transfer the money and data simultaneously. So the contracts are of this form that give the key when you receive certain payment. Or I would say the other way around, release the payment when you get the key. So it is all enforced using the smart contracts, and every blockchain platform, it has to be suitably written depending upon what sort of language the blockchain platform can support, and what sort of scripts or language the blockchain particular blockchain platform is able to support in this case. Yeah, that is the most that goes into the I would say the whole crux of this whole thing, that how do you write the smart contracts so that you could possibly enforce such a thing, and it is like it depends upon what platform. Okay, yeah, so this is a good question. What happens if the key doesn't match, and how does the reversal happen? So typically what happens is that is why you lock a collateral in the first place. So in case there is it does not match, then, and if there is this misbehavior happening, then you could ask for a reversal. You need a proof that you are not saying incorrect statement, or if you say that even receiving the correct key, you do not say that it is matching, then there is a way to figure out whether you are lying or you are not. Suppose you have been found lying, you are found to be truthful or honest in saying that the key is not matching, then the initial money that I said the seller was locking in, that goes to the buyer as a kind of a penalty for not giving the correct key. So again, this is again in the contract. So if this happens, if the correct key, then this money is released. If it is not the correct key, if there is a mismatch, then impose a penalty, and this is the penalty that you pay. So that is the whole contract that you would possibly write in such a case.